My screen is visible now. Yes. Is my screen
Yes,
visible?
sir. I see.
Okay. All right. We had left here. We are defining the conversion operator, and okay. So time 24. The original time 12 operator, like the time 12 class is here, and the constructors are over here. We are still defining function. We are overloading that constructor anyway. So this is ours. PM is equal to ours. That is 12. That false. That's true. And int round means seconds less than 30. Then we just say that, and we'll let these less than 30 seconds go. And otherwise, we will increase the number of minutes. And if round length equal 60, just 1 second, let me. Okay. Yeah. Now we will convert the extra minutes to hours. If this hours 24 equal 12, or 24 PM equals 2. So this will be true. So this is basically you toggle between AM and PM. And int hours 12 equals to 24 and 13. Right, and now we go to the main function. So the user should input the 24-hour time, like time in 24-hour format here in the following manner: hours. Go to 3 here. So we should let's put it in a loop. I think instead of doing this repeatedly, we can we just do it for one instance. Okay, so let's do it in a way so that it goes on if like we'll have to get out of this, no? So I guess let's do this. Right, so this is our constructor here, and no, this is not what we do. wait. Yeah, we don't have. I guess I wrote only one constructor. Yeah. So time 24 needs a 3-argument constructor. Yes. Now we can safely call the display function. Let's display it. Yeah. Okay. So let's see. Let me put something wrong. Oh. So this won't work. And let's put 14. Minutes is 10. Second is 15. So it should round down. Okay. Now, yes. This is displaying correctly, right? Okay. It's an object of the class time 12. Now we'll say 24. Performs the conversion here and okay. And this is also so this is 24 and yes. Name. Display. Okay. Yeah, so this works, and yeah, the conversion is right. Let's put something less than 12. Okay, yeah, this rounds down. Fine. Let's get out of it. Okay, this was a conversion between the two user-defined data types, time 12 and time 10, time 24. Okay, so now we can right. So now let's look at um, kind of restraining this kind of conversions. So we'll come across two keywords. First one is explicit. So let's see what this does. Just float, right? Okay. And here is one, the one argument constructor. Right. So this is the something, I mean, this is nothing new to us. Let's look at this function. So distance just 2.35. So this guy here uses still a one argument constructor, and so it's the out. This is just the display function for list one. Okay. Say float meters is equal to 3.0. And so let's define another function here. We need this. Just let me check once. Fine. So yeah, this is all right. Let me fancy this metric meters is yeah. So the thing is that what we see here Here we have defined, I mean, the function fancy list. It should take an object of the distance class. But you see that meters is a floating point variable, and our compiler is intelligent, so it doesn't like it automatically convert. I mean, does data conversion. So to restrain this, suppose for some reason I don't want such a thing to happen, I will use the keyword explicit. So you have seen that. So this one works, all right. What I'll do is what we should do is, okay, here I'll just add the keyword explicit. Means explicitly I'm like this should take you know. Okay, 1 second. So, what was the restraint? Restraint of dispensity. So fancy list is meters here, and right, and here it is. No, here it's a constructor of this class, right? So there should be an error here because now it should invoke this. So it should now stop the conversion from distance t to from an object of the distance class to float. Let's see if this compiler can. I mean, yeah, it should acknowledge the keyword explicit. Yes. Could not convert meters from float to distance. So it is reaching a contradiction because I'm explicitly restraining the conversion. Conversion cannot be done here. Similarly, I mean, okay, not similar, but another kind of restraining data conversions can be done with a more subtle keyword that is mutable. So the flavor is a little bit different here. Just okay. So recall that we use the keyword constant while referring to variables or even functions that do not change their values. Okay. So by default, if we like kind of the default understanding is that we want to change values of variables. Wherever we do not want, we keep things constant. Suppose you want something that is mostly constant. Mostly constant. So this is not restraining data conversions. This is like more like controlling the conversions. Yeah. Suppose you are dealing with something that is mostly constant. So what would you do if you want to change something there? Okay. Let's see. So this is some scroll bar kind of thing. This is size and this is a mutable string owner. We'll see how this is being used. Public scroll bar and size. size. Okay, void set size. Okay, now we will set a constant object. So 60 and window 1. And okay, fine. So this is constant, and just so let me string owner and set size 100. So size I'm trying to change. So the problem is here that passing constant string says argument blah blah blah. So the thing is that we have declared this object as constant, so we cannot change anything. And yes, so can we fine? So we cannot change this. We cannot change anything there. So let's try to, let's try to make a futile attempt to change the string here. This is window 1, right? So window 2. We cannot change it. So here, like due to the constant keyword here, the default setting is everything is constant, and so yeah. Now we will add the keyword mutable for string. No error. Let's see. what is happening. Yeah, so it has changed. So yeah, so this is how mutable works basically. And now just some generic knowledge about operator overloading. Uh, so okay, during this overloading, we should always remember that whatever function, I mean, whatever operation really overloading the operator with, it should be easy to understand, and it should be somehow an understandable generalization of the original operation. So if you overload plus plus, never like you overloaded function should never mean subtraction for anything else or multiplication for anything else, and so similar meanings should be used, and syntax should also be similar. Um, right. And another thing is that we should show some restraint because, um, yeah, so people are familiar with mostly the default operations of these things. So, yeah, so like kind of don't do this much. If it is not required, don't go for it. And so if you overload two operators, it should not, they should not lead to the same thing. And beware of operators for whom overloading is forbidden. So for example, the scope resolution operator is something that you cannot overload, and the member access operator, like the dot operator, is also one of them. And so the pointer to member operation, the arrow operator, that means that cannot also be overloaded, and yeah, so beware of such things. All right, so this was for today, and next week hopefully we'll start virtual functions, or we might go back to some of our old chapters, and or maybe we'll start virtual functions. It's high time that we complete this module. Anyway, so tomorrow there's a test from 11 to 1. Actually, I have not decided the final timing yet. It will surely start at 11, but it might be only 1.5 hours also. And yeah, so I think I'll set up 3 different exam rooms, and I'll send you a mail later, maybe tomorrow morning also, that which member room you have to join, and you should keep your cameras on the whole time, because your case will be invigilating. Hey, so yeah, best of luck for tomorrow. I'll see you in the morning.